So what we have here is a table of values, and in this table of values I plotted all of the points off to the right, and our goal is to come up with a line of best fit for this data. So a line of best fit is just like trying to find a shirt or a pair of pants that fit best. It's fairly subjective, but we do know what isn't the case. And so it wouldn't be the case that there would be a line going like in a weird direction on here. So with the line of best fit, I'm just going to try and sketch something in that fits this data the best I can. And as much as possible, a decent rule of thumb is to have some points on one side of the line and some points on the other side. So it might look something like this. So that's the line that fits this data. And I need to come up with an equation for this line. And the way I can do that is I need to pick 2 points. I can pick any 2 points I want. Ideally, I'm going to pick 2 points that are close to the line and far away from each other. So I'm going to choose this point up here to work with and this point down here to work with. And their coordinates happen to be, this one is 7, 548 from the table. And this point looks to be 2 and 322. And I'm going to use those points to approximate my line. Now, we know from the work we've done recently that one equation of a line is point-slope form. And this is an example where point-slope form is going to be really nice to work with. So let me remind you that it's y minus y1 equals m times x minus x1. I need to know the slope. So the slope is y2 minus y1, or in this case 548 minus 322, all over x2 minus x1, so 7 minus 2. This simplifies down to, what is that, 6, 226 over 5. That's the slope of my line. And in point-slope form, I just have to pick one of those points to work with. So my equation would be y minus 322 equals 226 over 5 times x minus 2. Now, lines of best fit, a lot of times people want them in a function form. So I can't really stop here. I need to keep going. But I do know that to get this into a function form, or in slope-intercept form, I'll need to distribute. And that will be 452 over 5. And then I'm going to add 322. And I can just see Josh right now wondering what the common denominator is going to be, because he knows what he's doing. And hopefully he can see that it's going to have to be 5. So to add these two like terms together, I'm going to need a common denominator. So y equals 226 over 5x minus 452 over 5 plus 1610 over 5. And now that I've gotten the same common denominator as Josh, I end up with this: y equals 226 over 5x plus 1149 over 5. So this is our approximation for our line of best fit. Its equation.